Good morning, everyone, and welcome to today's webinar, Using SSPC PA2 Effectively. We're glad that you're joining us this morning. My name is Josiah Lockley. I'm the moderator for today's webinar, and I'm with JPCL and PaintSquare. This webinar is organized by SSPC and JPCL and is part of our 2017 SSPC JPCL webinar series. Now, before we begin, I'd like to take a moment to thank today's sponsor, DeFelsco Inspection Instruments. DeFelsco is a leading U.S. manufacturer of inspection instruments using the Positector series of interchangeable probes for measuring coating thickness, profile, environmental conditions, salt contamination, shore hardness, and wall thickness. Products include the Positector 6000 series of coating thickness gauges, the Positector SST soluble salt tester for measuring soluble salt contamination using the Bresel method, the Positest LPD low voltage pinhole detector for detecting holidays, discontinuities, and other flaws in coatings, and the Positector shore hardness durometer for measuring the hardness of pipe wraps, plastics, rubbers, and more. Visit www.defelsco.com to get assistance selecting the optimal instrument for your application. Let's talk about the format for today's webinar. The presentation today from Bill Corbett of KTA Tater Incorporated will last roughly 45 minutes and then be followed by a 10-minute question and answer session. To send us a question, just use the questions chat box that you should see located on the right-hand side of your screen through the GoToWebinar control panel. You can also use the questions chat box to send any outstanding issues you might have occurring during the webinar, and we'll do the best we can to answer them during the webinar as well. There is a test for those who wish to receive continuing education credits from SSPC. The test is $25 to take, but is free for SSPC members, and you can find it by taking the test at sspc.org/market-place. There you'll receive one certification unit through SSPC and the Florida Board of Professional Engineers. Again, please visit www.sspc.org/marketplace. We are currently recording this presentation, and we will make it available for download at PaintSquare.com/webinars. Also look for a copy of the slides posted by the end of the presentation today. Again, just go to PaintSquare.com/webinars, click on the title of today's webinar, Using SSPC PA2 Effectively, and we'll have that information all posted roughly by around 5 p.m. Eastern Time today. Now, before we begin, it's my pleasure to introduce today's speaker, Bill Corbett of KTA Tater Incorporated. Bill is the Chief Operations Officer for KTA Tater Incorporated, where he has been employed for 38 years. He holds an AD in Business Administration from Robert Morris University. He is an SSPC Certified Protective Coating Specialist, an SSPC Level 3 Certified Coatings Inspector, and a Level 2 Certified Bridge Coatings Inspector, as well as a NACE Level 3 Certified Coatings Inspector. He is an approved training course instructor for both SSPC and KTA. He received SSPC's Coating Education Award in 2006, the John D. Keene Award of Merit in 2011, and the President's Lecture Series Award in 2017. He is the chair of the SSPC Dry Film Thickness Committee and chair of the SSPC Education and Certification Committee. He is also a member of ASTM subcommittees D123 and D146. Now at this point, I'm going to turn the presentation over to Bill.
Okay, Josiah, we're good to go?
Yep, take it away, Bill.
Okay, thank you. All right, well, folks, thanks for joining us today. We're going to spend, as Josiah said, about the next 45 minutes or so talking about SSPC's standard for coating thickness, and that's known as the Paint Application Standard number 2, and the title is on the slide there, and that title has changed over the past 5 to 7 years or so, but that's the current title of the document. So we're going to be discussing a lot of topics today related to this single standard. We're going to talk about the background and purpose of the standard, and then we're also going to speak briefly about a sister document, if you will, or a complementary document known as ASTM's standard for dry film thickness measurement, which is D7091. We're also going to discuss a few basic definitions that are listed in the SSPC PA2 standard. We'll look at some gauge descriptions and then define some terms like calibration, verification of accuracy, and adjustment. We're also going to talk about some measurement acquisition processes. For example, the number of gauge readings that are supposed to be taken, the number of spot measurements, and the number of area measurements that are supposed to be taken to conform to this standard. We're also going to discuss, just how far out of specification the measurements can be and still be acceptable. In other words, there's a tolerance to those acquired measurements according to the standard. And then currently there are 9 non-mandatory appendices to the standard, and we're going to spend a few minutes highlighting the information that's in those and discuss potential for a 10th appendices that may be in the works. So like any webinar, it's important that we establish our learning objectives or outcomes up front. So when we're done with this webinar, these are the things that we're hopeful you're a little more comfortable with, and that's being able to describe the purpose and content of SSPC PA2, be able to describe the basic differences between a type 1 magnetic pull-off and a type 2 electronic gauge, describe the procedures for frequency of gauge calibration, verification of accuracy and adjustment, and just what each of those terms truly means. Be able to explain base metal reading and describe when and how to obtain it, and then what its significance is related to true coating thickness. Being able to describe the number of coating thickness measurements to obtain and just how far out of tolerance those can be and still conform to the specification. Be able to describe when you do have thicknesses that are out of specification, determining how bad is the problem. Is it localized or is it a large spread or a widespread issue, and how to determine that. And then be able to describe the basic content and purpose of the appendices to the standard and what they're designed to do and when they're invoked. So, before we launch into the current standard, I thought it was important to give you a little perspective on the history of the standard. This document was originally published about 45 years ago, actually, as a temporary standard. That's what the T stands for in parentheses on the slide there. And at that time, the standard referenced gauges like the one that's shown just in the upper corner of the document there on the slide. And many of those gauges that it referenced back in 1973 are actually obsolete now. And the standard has been updated on multiple occasions. Most recently, the standard was republished, I should say, in January of 2015. There were a few editorial tweaks or updates that were published in August of 2016. So we've had the current document in place now for almost a year. And those editorial revisions were very minor. So in nearly the same time frame, whenever SSPC PA2 was really being overhauled, this goes back to 2005, the ASTM standard on coating thickness measurement, which is ASTM D7091, was also being revised and updated, and it was published in 2012. The most current version of the ASTM standard really focuses on how to use dry film thickness gauges properly, while PA2 focuses primarily on the acceptability of those measurements. So any references to how many measurements to take were removed from the ASTM standard. So these two documents really complement one another quite nicely right now, and we often see them used in conjunction with one another because they don't conflict. It's also important to note that both documents now address measurement of coating thickness on both ferrous metal and non-ferrous metal substrates. Prior to 2012, SSPC PA2 only addressed measurement of coatings on steel. So SSPC's PA2 standard is very commonly, we see it specified a lot, and we think is because it's a fairly robust document, and there's also, you know, not a lot of competing documents out there, which is actually good. It describes procedures for measuring the thickness of non-magnetic coatings that are applied to a ferrous and a non-ferrous metal substrate. According to the standard, coating thickness measurements are obtained using 2 commercially available gauges, and there are a lot of manufacturers of these gauges across the US and overseas. Now, you're going to see a few gauges, of course, in some of the slides that are shown throughout this webinar, but there's no intent on my part to show any favoritism of one gauge over another. We tried to show a cross-section of some of the gauges that are available, but we certainly don't mean to not highlight someone or highlight someone. PA2 describes procedures for gauge calibration, verification of accuracy using traceable coded standards. It talks about gauge adjustment and measurement acquisition. And it also provides a way or a procedure to determine whether or not the applied coating meets the specified thickness range over the areas that were coated on a structure. And again, there are 9 non-mandatory appendices that we're going to talk about a little bit later. So there's some definitions or some terms that we need to get out of the way first, because later on in the webinar I'm going to be using these terms, so it's important we establish a baseline up front. So a gauge reading is a single instrument reading. So we place the gauge down one time, it reveals a reading to us, and we call that a gauge reading. That's pretty straightforward. A spot measurement, though, is a little less obvious. A spot measurement, according to PA2, is the average of 3 or at least 3 gauge readings made within a 1.5-inch diameter circle. So about the diameter of a 25-cent piece or a 50-cent piece here in the U.S. That's about the diameter that we're looking at. So 3 readings, or at least 3 in that area. An area measurement is 5 spot measurements that are distributed over 100 square feet of coated surface. There was another definition that was added in 2015, and that's coated or plated metal plates, and that often contains an uncoated plate for a 0 reference, and these have assigned values to them that are traceable to a national metrology institution. Uncoated shims of flat plastic sheet with assigned values that are also traceable to that national metrology institution are also considered certified standards. We call these certified shims. But these certified standards or certified shims that are placed on a smooth surface, in the case of shims, are used to verify the accuracy of the gauge before use, and we'll describe that in a few minutes. So the gauge type is determined by the magnetic properties that are used, or the eddy current properties that are used to measure the thickness of the coating, and it's not really related to the mode of data readout. For example, does it read out analog or does it read out digital? It's how it takes the measurement. So type 1 gauges, according to SSPC PA2, are called magnetic pull-off gauges, and type 2 gauges are an electronic gauge. The standard does not address gauges that measure coating thickness on non-ferrous surfaces like concrete or wood or other non-metal, non-magnetic surfaces. So coating thickness measurement on these surfaces are described in a different document, and that's SSPC PA9. The corresponding ASTM standard in that case is D6132. So here on the slide you see in front of you, on the left-hand side, you've got examples from 3 manufacturers of type 1 magnetic pull-off gauges, different ranges. On the right-hand side, you see a selection of type 2 electronic gauges from several different manufacturers. So you can see the difference, where the magnetic pull-off type versus the electronic type. So quickly on the type 1 pull-off gauges, a permanent magnet is brought into direct contact with the coated surface, and the force necessary to pull the magnet from the surface is measured and indicated on the coating thickness dial. It's actually an analog scale. Of course, less force is required to remove the magnet from a thick coating relative to the force that would require to remove the magnet from a thin coating, because of course the magnet over a thin coating would be closer to the metal surface. These gauges can only be used on steel. Now, these type 1 gauges have what we call a non-linear scale. So any type of adjustment you would make would be linear. So that's going to limit the dry film thickness range in which these gauges will provide accurate readings. And so we don't recommend making any adjustments to these scales. Some people will apply a correction value, saying that, well, if their gauge is reading a 1/2 mil high on the coated standard, they simply deduct a 1/2 mil from all their coating thickness measurements. The problem with that is that that single correction factor may not represent every single thickness, full scale, or half the scale, or a third of the scale, because any correction would be nonlinear. So that is also pointed out in PA2 is not a recommended practice. Type 2 gauges, on the other hand, they use electronic circuitry to convert a reference signal into coating thickness. In general, type 2 gauges are typically more accurate than type 1 gauges. The data acquisition is a lot faster, and these gauges can obviously, because of software, be able to store readings. They can provide statistical analysis of the data, and then once that data is generated and stored, now we can upload it into a computer software program or download it to a printer. So it removes some of the manual recording of readings. I also want to note at this point that many gauge manufacturers now offer what we call scanning probe technology, so a user can obtain a lot more readings without substantially increasing data acquisition time. And we're going to talk about scanning probes a little bit later on. The ASTM D7091 standard and the PA2 standard describe 3 steps associated with assuring that you're getting accurate measurements with these gauges. And that includes gauge calibration, verification of accuracy, and then adjustment. And according to the PA2 standard, and for that matter, the ASTM standard, each of these steps needs to be completed before coating thickness measurements are required to determine whether or not the applied coating meets the requirements of the project specification. Coating thickness gauges must be calibrated by the manufacturer or an accredited calibration laboratory. A test certificate or other documentation showing traceability to a National Metrology Institute is required. There's no standard time interval for recalibration, nor is one absolutely required. Calibration intervals are usually established based on experience in the work environment. For example, if the gauge is being used on a daily basis in a very rigorous environment, the calibration interval may be 6 months, where if it's used once a week in a rather benign environment, a 1-year calibration may be a good starting point, and 1 year is often suggested by gauge manufacturers. So to verify the accuracy of type 1 gauges, now we're switching from calibration now over to verification of accuracy. So calibration is done by an accredited calibration lab or the manufacturer, where verification is done by the gauge user. And verification of type 1 gauges is done by measuring the thickness of a series of coded reference standards covering the expected range of coating thickness. So we don't want to obtain measurements of the coating thickness with an inaccurate gauge, so we want to check the thickness of something that we know the thickness of before we start checking the thickness of something that we don't know the thickness of. We don't know the thickness of the coating that was applied. We're trying to determine that, but we want to make sure our gauge is working right, so we verify its accuracy on something that we know is accurate. And typically this is done before and after each period of use. Most people interpret that as work shift. If they're going to use it during the work shift, they check at the beginning and the end. But if you drop the gauge or suspect it's giving some odd readings, it's recommended to recheck that. Also, unless a gauge manufacturer explicitly allows it, certified shims used to verify the accuracy of type 2 gauges should not be used with type 1 gauges, again, unless the gauge manufacturer allows it. When documenting gauge adjustment processes, some of the things you want to record include the serial number of the gauge, the reference standard that was used, the certified or coded standard that you used to verify accuracy, the stated thickness of the reference standard, and then the measured thickness, and they should be reasonably close. The method used to verify gauge accuracy. Now, if you're going to use the same gauge, the same reference standard, and the same method of verification throughout a job, typically they're only recorded once. All right. Now, let's say, for example, that you determine that the gauge doesn't match the value on the coded standard or standards that you checked it on. Now what do you do? Well, these type 1 gauges cannot and should not be adjusted. And in fact, any adjustments made to the wound spring within the first year can void the warranty on the gauge. So we typically don't recommend that to be done. So you can verify the accuracy on the coded standard, and they are allowed to be a little bit out of tolerance. And how you determine, how far is too much is you take the accuracy of the gauge and square that value, and the accuracy of the reference standard and square that value, and combine those two values and take the square root of that sum. So for example, if the gauge accuracy is 5% and the reference standard accuracy is 3%, if we square 5 and square 3, we get a total of about 36, which is, or sorry, 38 or so. So that's going to give us about a 6% tolerance. So on a 10 mil reference standard, as long as our gauge is reading anywhere from 9.5 to 10.5 mils, we can consider that gauge accurate, even though it's not perfect, because every gauge and every coded standard has a tolerance. I should also mention that if it's outside of the combined tolerance of the coded standard and the thickness gauge, that gauge should be tagged and taken out of service. So the next step, and assuming we have a accurate gauge, is to determine the effect of any surface roughness that may be on the surface as a result of abrasive blast cleaning or impact type power tools or things like that. Recognizing the fact that when we see a specified dry film thickness, that's intended to be meant from the tops of the peaks of the surface profile. And on the slide, that's depicted by the thick yellow bar in the bottom right-hand corner. That's the coating, if you will. Most coating thickness gauges, in order to satisfy the magnetic properties or the eddy current properties, will reach down into the surface roughness partway, hypothetical plane, to satisfy the properties of the gauge, and that's depicted by that thin yellow bar in the same diagram on the slide. You see it's partway down into a simulated surface profile. Now, I don't know that line is drawn in the correct position. It might need to be a little higher, a little lower, but it's just meant to indicate that the gauge is reaching down into that roughness a certain amount. And that's the effect of surface roughness on a thickness gauge, and ultimately that's measured and deducted from the coating thickness. So we're removing that gap, if you will, between the thick yellow bar and the thin yellow bar. We refer to that as a base metal reading, and that's the effect of surface roughness on a coating thickness gauge, and it's very important that you do not consider that surface profile. Surface profile is the maximum peak to valley depth. What we're showing here is the effect of that roughness on a coating thickness gauge, and in fact there's no correlation between the two. And one of the worst things you can do is deduct profile from your coating thickness. You'd never want to do that. All you would want to do is deduct the effect of the base metal on the coating thickness gauge from your coating thickness. So once you verify the accuracy of a type 1 gauge, measure the base metal reading. And we do that by taking maybe 10 or 12 readings across the surface and taking an average, and ultimately that's deducted from the coating thickness. So here we have 10 measurements that were taken. The average base metal reading is 0.8 of a mil. So if we measured a coating thickness at 5 mils, the amount of paint from the tops to the peaks would be considered 4.2 mils, which is 5 minus 0.8. Here's an example where we've measured a primer at 4 mils, removed a base metal effect of 1/2 mil, showing the actual primer thickness at 3.5 mils. Now, when we measure the cumulative thickness of primer and finish, we have a cumulative thickness of 7 mils, a 1/2 mil base metal effect, so our actual total system thickness, in this case, primer and finish coat, is only 6.5 mils from the peaks up. We're removing that base metal effect from our coating thickness measurements. But this begs the question, what if you don't have access to the bare blast clean surface? What do you do? Do you just guess at a number? Do you guess at a base metal reading? Well, actually, Appendix 8 in the PA2 standard gives some guidance here. So first, you want to verify the accuracy of the gauge on a smooth reference standard or a traceable coated standard like we discussed. So any values you measure on the coated surface are going to be a little bit higher than the true coating thickness. So we have to deduct an assumed approximate correction value from each gauge reading. So here's table A8 from the standard, and this actually comes out of an ISO standard that says that if you have a fine surface profile, they don't define fine, but they say, for example, if it's maybe 1 to 2 mils, you might have a correction factor of 0.4 mil. But if you have a medium profile, maybe 2.5 to 3.5 mils, something like that, maybe a 1 mil deduction is appropriate. And then if you have a very heavy profile, for example, maybe 4 to 5 mil surface profile, you might have 1.5 mils that you need to deduct. These are approximate values, so we recognize something because we just don't have access to the bare metal in all cases. So for type 2 gauges, things really don't change at this point. We're still going to verify the accuracy of the gauge using coded standards, all right? Many folks will use shims at this stage, and that's really not correct. Use of shims on a prepared, uncoated surface is not considered verifying gauge accuracy. It might be considered adjustment, but it's not considered gauge accuracy since the effect of the roughened substrate underneath the shim is unknown. We can't verify the accuracy of the gauge on an unknown surface. So it's got to be a flat metal surface with a certified shim or use a certified coated standard. So when you're verifying the accuracy of type 2 gauges, you can either use a single point or a 2-point. Single point is you just check one standard. For example, if you're going to measure 4 to 6 mils, check it on a 5 mil reference standard. A 2-point verification is a little better. So for example, if you're going to measure that same maybe 5 mils, maybe check the gauge at 3 mils and check the gauge at 7 mils on the coded standards. So we're going to do a 2-point verification, and that way we establish a range of accuracy for that gauge in that range of use. And then our final step here is doing an adjustment. And what this does is this improves the gauge accuracy to correct for things like surface roughness, the metallurgy, the curvature, other properties of the actual steel that was coated. And this is where our certified or measured shims come in handy, because we can place those right on the prepared, uncoated steel and adjust the gauge to match the shim thickness. Right. And there's specific information in Appendix 8 on how to do this, and we do recommend that you follow the gauge manufacturer's step-by-step process for this, but all we're doing is we're setting the gauge down on a known thickness, a measured shim, over top of the prepared metal, and making any final gauge adjustments so that the gauge matches the gauge reading, matches the shim. So now we're only recognizing what is resting on the peaks of the profile. So naturally there's no base metal reading to measure or deduct in this case. We're compensating for that by using the measured or certified shim. So now I want to move over to frequency of measurement. So we're going to kind of leave D7091 now and really focus on PA2 because D7091 doesn't have this information in it. The figure you see on the slide here was extracted from PA2, and it shows what we mean by gauge readings. You see we have 3 per spot. What we mean by spot measurements, we have 5 of those. And then what we mean by area, and that's approximately 100 square feet. So in total, we have essentially a minimum of 15 gauge readings composing 5 spot measurements, composing 1 area measurement. So what we do inside each 100 square foot area doesn't change. It's always at least 3 gauge readings per spot, and it's always 5 spot measurements per area. That doesn't change. What changes, though, is the number of areas that we measure. So for areas of, let me back up for a second. Prior to 2004 version, the standard based the number of areas to measure on the size of the structure. And that caused a lot of problems because in some cases, people considered a shop the structure, and really what we meant was the steel inside the shop that was being coated. And some of these larger structures, you know, millions of square feet, we weren't getting enough coating thickness measurements. So it's based on what we call the coated area now, and most people interpret that as what was coated during the work shift. All right. I also want to mention that the data that's shown here is always in square feet, but there's also a metric version of this, which is one of the editorial changes that was made in 2016. So that information is in the standard. So if you have an area of coating that was done during the previous shift and it was less than 300 square feet, you measure every 100 square feet. If the area that was coated was between 300 and 1,000, you don't measure every 100 square feet, you measure 3 random 100 square foot areas. So if you had 900 square feet, you'd measure 3 areas. If you had 500 square feet, you'd measure 3 areas. This is the most complex one. It's the 3rd tier, and that's for areas exceeding 1,000 square feet. You're going to measure 3 areas in the first 1,000 square feet that was coated, and then 1 more area for each additional 1,000 square feet that was coated during the shift or portion thereof. All right. Now, any project specification can be more restrictive. They can tell you to measure every square foot on a structure if they'd like, but if they invoke PA2 without giving any other guidance, this is the measurement frequency. This is a drawing that was part of a training class, and it illustrates the 3 different tiers. The top 3rd is less than 300 square feet. The middle tier, if you will, is between 300 and 1,000 square feet, and then the bottom one is illustrating greater than 1,000 square feet, where you're checking 3 areas in the first 1,000 square feet at the very bottom of the slide, and 1 more for each 1,000 square feet or portion thereof. You see we've got the top portion there of the bottom 1/3 of the slide is only 500 square feet, so we're measuring 1 area there as well. Here's an example of 900 square feet was what was coated. We're measuring 3 areas, 5 spots per area, so we've got 15 spot measurements. If we only took 3 gauge readings at each spot, we'd have a total of 45 gauge readings over the 900 square feet. Here we have a much larger area that was coated during the shift, 12,500. So as far as PA2 is concerned, we've got 13,000 square feet because we've got 12,000 plus a portion. So we have 13,000 square feet. So we're going to measure 3 areas in the first 1,000. So now we're down to 12,000. 1 more for each additional area, 12 more, gives us a total of 15 areas. And then times 5 times 3, 5 spot measurements per area, 3 gauge readings per spot. One of the things that has caused some problems in the past is coating specifications may provide the contractor with a single value, or product data sheet may say to put on 3 mils of coating, and that's impossible to achieve. So what PA2 said is when a single thickness value is specified and there's no range given by the manufacturer of the coating, PA2 allows the applicator to establish the range at plus or minus 20% of the target. So if the specification and data sheet say to apply 7 mils of primer, the leeway for that primer layer would be anywhere from about 5.5 to 8.5 mils, even though the spec wanted 7, because it is impossible to achieve 7 mils dry film thickness across the structure. Another change that was made in 2012 was the addition of these thickness restriction level tables. And it's a little confusing to look at, but in the second column over, you have the gauge reading, and it doesn't matter what level you're looking at. The gauge readings are always unrestricted. And what PA2 says is if you take a gauge reading and it's not representative of the spot, it's unusually high or low, you're allowed to discard it. The third column over says spot reading. That actually should say spot measurement, right? It varies a little bit depending on the level. If a level 1 restriction level is specified, the spot reading cannot vary from the minimum and maximum thickness specified. If level 2 is specified, the spot measurement cannot fall below the minimum, but we're allowed to go over 20% on the maximum side. Level 3 is the default, if you will. If no level is specified, level 3 becomes the default, and that means that any spot measurement can be 20% light or 20% heavy of the specified min and max. And then level 4 and level 5 become even less restrictive. But you can see outside of level 5, the area measurement must always be within the specified thickness range. The maximum thickness is unrestricted for level 5. Again, I want to stress that if, and we find this in most cases, that if PA2 is specified and a thickness restriction level is not specified, the default is level 3. And this just runs through some examples of those applications. So if we had a it says target dry film on the slide. It should say dry film thickness range 4 to 6 mils. Level 3 has been specified, or it's the default. Again, individual gauge readings can be anything. The spot measurements can be 20% light or 20% heavy. In this case, 3.2 to 7.2. But the area measurement has to be within the specified range of 4 to 6 mils. If the spot or area measurements are out of tolerance, then we have to find out how bad the problem is. Very, very similar example. The only thing we changed here was level 2 on the restriction level. And in this case, you can see we can't fall below the minimum of 4 mils, but we're allowed 20% over on the 6 mil high side. And this is just a quick reminder that many manufacturers have PA2 built into or programmed into their measurement tolerance software supplied with the gauges. And one example of one of the manufacturers is shown on the slide here. Is probably an old example. So let's say we have spot or area measurements that are out of tolerance. The previous versions, going back to 2004 of PA2, said essentially if you find an out of tolerance spot or area, you're supposed to measure every 100 square foot that was coated during that shift, and that could actually significantly impact production. So we really looked hard at that when we redid the standard and came up with what we feel is a much better approach. Now there's a lot of words on this slide, and what I'd like to do is go to the next slide and show an illustration of what these words say. It's just a little easier to look at. So let's say that in the middle of the slide there, we've got an initial non-conforming 100 square foot area. Whether it was a bad spot or bad area, doesn't matter. It's a non-conforming area. So what the committee decided to do is actually kind of do what you find inspectors doing in the field anyways, is they start radiating out from that non-conforming area to find out just how bad the problem is. Is it isolated or is it widespread? So we're going out in approximate, it doesn't have to be exact, approximate 5-foot distances and taking additional spot measurements. So every green circle you see on the slide where they either say okay or no, those are spots. Those are not whole areas. That's setting the gauge down 3 times. So if we go out 5 feet and we find a spot that's okay, we're going to go out another 5 feet and make sure that we're still okay. When we get 2 spots 5 foot apart that appear to be in specification, we stop measuring. Or if we reach the boundary of what was done during that work shift, we stop. So you can see on the 6 o'clock one, we were only able to go out 1 5 foot. We couldn't go out a second one because now we're going to go into previous shift's work, and we don't want to do that. So we're radiating out from the problem, and we're going to identify it, demarcate it, and then the applicator can come and correct that area or whatever the resolution to the non-conforming area is in that case. So it seems to make a little bit more sense and a little bit more productive. So now we're going to move into the last section of PA2, and that's section 10. And section 10 was added because the reporting section in ASTM didn't match up real well with taking coating thickness measurements in the field. So we thought its own reporting section was important. So we're going to, list the type of instrument used, the manufacturer, model, serial number, data calibration, all that good stuff. The type of certified standard that we use to verify gauge accuracy, the thickness of the measured shim that we use to adjust a type 2 gauge if we did an adjustment in the field over the prepared metal. If we decided we wanted to take a base metal reading and deduct it from our coating thickness measurements, that's fine, but we need to record whatever that base metal reading was. We're going to record the spot and area measurements, and then the name of the gauge operator and the date that the measurements were taken. Now, the individual gauge readings don't have to be recorded, but a specification obviously can override that and may want those to be recorded. Okay, I've got about 10 minutes, and I'm going to try to get through some of the details of these appendices that are in the standard, and that should finish us up. Now, we're going to be focusing on really appendices 2 through 7 and number 9, because we've already really talked about the numerical example of average thickness measurements. Those are the diagrams that show the different areas and spot measurements. We've already talked about that. And then Appendix 8, which is how to properly adjust type 2 gauges using measured or certified shims. We've already discussed that as well. So we won't focus on all of these, but we're going to hit most of them. And the ones we're going to talk about are in yellow font. So the Appendix 2 provides a frequency for measuring coating thickness on steel beams or girders. We've got a full determination and a sample determination. Sample determination is based on 2 lengths of steel I-beams, less than 20 feet and 20 to 60 feet in length. The tolerance of each of the spot measurements is always the default restriction level, and that's the 80-120 rule, if you will. So the spot readings can be 20% light or 20% heavy. When we average everything together, it's got to meet the specified thickness range. And then measurements are arbitrarily taken on any stiffeners that might be across the beams. From flange to flange along the web. So for a full determination on these beams, the total length of the beam, doesn't matter how long it is, it's divided into 5 sections. So if you had a 75-foot long beam, you've got 5 15-foot sections. If you've got a steel beam that's fabricated with a web that's greater or equal to 36 inch in height, we only get 1 spot measurement in each of 14 locations. But if you've got a web that is less than 36 inches, we're only going to take 12 locations per section. And I'm going to show you where those 14 or 12 locations are. But for the bigger web, we're going to take an extra measurement on both sides of the web. That's why we're jumping from 12 to 14. So here are our locations. Note on the larger beam, the one on the right, we've got 2 spot measurements on either side of the web. So we've got a total of 14 spot measurements around the wrap of the I-beam, if you will. And we're going to do this, 5 times down the length of the beam in each of the 5 sections. There are certain areas that may not be measured. For example, if the top flange is going to be embedded in concrete, it might get a mist coat of primer, but we're typically not going to measure that. And then if the flange edges are less than 1 inch, typically we're going to ignore those as well. And then the sample determination is basically if you have a beam that's less than 20 foot, I'm going to take 2 spot measurements that are randomly distributed in all 12 areas. So you're going to get a total of 24 measurements along the beam. And those 12 locations are per the previous figure. And then if you've got a beam between 20 and 60 feet, you'll take 3 spot measurements in all 12 areas or get 36 spot measurements. So this is a sample versus a full determination. And then finally, this appendix talks about laydown, which is a group of steel members that are laid down and coated in one shift by a single applicator. For example, what you see on the slide here. So we can do a full determination or a sample determination on these beams that are coated. Appendix 4, I'll cover that pretty quickly for those of you that coat test panels. They have 2 appendices for that. This is minimum panel size of 3 inches by 6 inches and maximum of 12 inches by 12 inches. Using a properly adjusted type 2 gauge, you take 2 readings from the top, middle, and bottom thirds. Each reading you want to be at least 1/2 inch from any panel edge and then at least 1 inch from any other gauge reading. And PA2 establishes the 20% low and 20% high to the gauge readings for each spot measurement. For thin coatings that are, and thin is defined as 1 mil or less, or 25 microns or less, you take a lot more readings because there's typically going to be higher variability in this. 10 readings from each of 3 zones. You got a total of 30 measurements on these. And there's restrictions on smaller test panels and how far away from edges you're allowed to be. Typically it's 1/2 inch. And unusually high or low gauge readings can be discarded, but the dry film thickness of the coating on a test panel is the average of all 3 of those zones. So some of you that have been in the industry a while will say, oh, we've always been taught to stay away from edges. Never measure the coating thickness anywhere closer than 1 inch from any edge. Well, technology's changed. We've got probes now that work well on edges. So PA2, in keeping up with technology, added Appendix 6 several years ago to enable a user to measure the coating thickness on the edges using microprobes. And SSPC Guide 11, which is actually being overhauled right now, discusses edge retentive coatings and how to measure the coating on edges if that's desirable. Of course, you want to verify the accuracy of the gauge using the microprobe on a shim on an edge because that's going to be different than verifying accuracy on a smooth coated standard where we know it'll work well. And take a minimum of 3 gauge readings within 1.5 inch linear inches along the edge, and that's considered a spot measurement. The number of spot measurements obviously is going to be dictated by the length of the edge. But that's up to the individual users. This is just kind of a non-mandatory appendix giving some guidance if someone is interested in measuring edge retentive properties of the coating itself on edges. So Appendix 7 talks a little bit about measuring coating on steel pipe exteriors. So pipe sections on a cart or rack are considered a complete unit. And to determine the total area, multiply the length of each type by the circumference, or pi times diameter. And then you're going to multiply that by the number of pipe sections on the cart. An alternative to that is the document actually includes 5 pipe dry film thickness, what we call frequency factors. And so for example, you can multiply the length of each pipe by the circumference and multiply that by the number of pipe sections on the cart, like we talked about earlier. And that'll give you the number of spot measurements. But then what you can do is apply what we call a frequency factor. And the total number of spot measurements can then be multiplied by 2, 3, 4, 5, or 6, depending on how thorough you want to be on this cart of parts and pieces of pipe sections. A little simpler are when we have nice clean pipe spools that are measured individually, and table A7 that was pulled from the PA2 standard, and it's appearing before you there on the screen. So for pipe diameters up to 12 inches, you want to take 4 evenly spaced circumferential spot measurements at 10-foot intervals. And those, what we mean by 4 evenly spaced is maybe 12 o'clock, 3 o'clock, 6 o'clock, 9 o'clock. So you're hitting, top, bottom, and both sides of the pipe. And you can see as the pipe diameter gets larger, you're going to take more spot measurements. 14 to 24 inch diameter pipe, you've got 6 spot measurements. If the pipe is over 24 inches, you're going to take 8 spot measurements, again, around the circumference of the pipe, not just where it's convenient. Of course, where it's difficult to coat, the underside of the pipe, that's where you want to make sure that you're getting measurements in those areas as well. So kind of to pull this all together, we've got maybe another minute to talk. Before I get into the summary, another minute to talk about scanning probe technology. I want to let you all know where that's at. Many of the manufacturers have scanning probe, or what we call continuous readout mode properties now, and there are certain agencies that are interested in getting a lot more coating thickness data than what PA2 does. PA2 is not a statistical representation of the structure. It was never meant to be a statistically based document. In order to get a statistically valid sampling, you have to take a lot more measurements. Well, that's going to mean a lot more time. So an alternative to that is to use a scanning probe that can ride along the surface, get a lot more data, and now you've got all that data that you have to manage, which is another task, and what is an outlier and all those big questions. But you can gather a lot more data without significantly impacting production. There was a presentation given by a few folks at the SSPC 2017 conference to the industry saying, are you guys even interested in this? And the general thought was, yeah, it's interesting, but don't make it a mandatory part of PA2. Make it an appendix, which is non-mandatory, and then if an owner, like an agency, wants to specify it, they can say measure in accordance with PA2 Appendix 10, which means you're going to use scanning probe technology, you're going to get a lot more data, et cetera, et cetera. So that's kind of the path that the committee will likely proceed with, but it hasn't come formally in front of the committee at this point. So that's where we're at. So to summarize this webinar, we've talked about the background and purpose of the PA2 standard, talked about the purpose of the complementary ASTM standard practice for coating thickness measurement and how they work well together. Talked about the basic definitions that are listed in the standard to equal or level the playing field there. Talked about gauge descriptions and procedures for calibration, what that means, verification of accuracy, what that means, who's responsible for doing that, and then adjustment. We talked about how to get measurements and how many measurements to take, how many gauge readings, how many spot measurements, how many area measurements based on the coated area. And then if we have a spot measurement or an area measurement that falls out of tolerance, what do we do now? How do we determine the magnitude of that non-conforming area? We've got a procedure for that in PA2. And then we real quickly covered the content of the 9 appendices that are currently in the standard. Of course, appendices may be added in the future. So I want to thank you all for listening to me for the past 45 minutes or so. I think we still have some time for a few questions, and I'll turn the presentation over to Josiah. And we are in 2 different locations, so he'll have to read the questions to me, and I'll do the best to answer them. I also have a copy of the current PA2 standard in front of me if I need to reference it. Josiah?
All right, fantastic. Thanks again, Bill, for a great presentation. We do have time for a handful of questions, so please, I recommend anybody who's got questions, send them over to us via the GoToWebinar chat box that you should see located on the right-hand side of your screen, and we'll try to answer as many as we can in the time that we have. So let's get going here. We have some questions that have come in the last 10 minutes or so. This attendee asks, what if I have to measure new coatings over weldings in paint shop prepared plates?
If you're actually talking about measuring the coating over a weld itself, that can be very difficult because welds may or may not be rough. The only thing that I would do there is definitely you want to look at using a microprobe for that purpose. And before using it to measure coating thickness, place a measured or certified shim down on an uncoated weld that's similar and make sure that the gauge is reading the shim thickness properly. If it isn't, then it's not feasible to measure it over the weld itself.
Okay. Another question that has just come in here is in regards to spot measurements. Is there a rule of thumb for statistical significance of the sampling?
No, as I mentioned earlier, SSPCA2 was, and I want to be careful here because I don't want to speak for SSPC or the committee, but my understanding is the document was put out as a practical approach, not a statistical approach, but a practical approach to gathering enough data to get some level of confidence that the coating thickness is reasonably uniform across the area that was measured. In order to get and I'm not a statistician, but in order to get a statistical sampling, my understanding is that a lot more gauge readings, spot measurements, and area measurements would be necessary, which goes to the scanning probe technology.
Okay, we have two questions that have come in here. They're both in regards to type 1 gauges and BMR. The first one is just a quick follow-up. This attendee wants to confirm that BMR is not suited for type 2 and is only suited for type 1. Is that correct?
Yeah, that is a misconception. Whether or not you obtain a base metal reading is completely unrelated to the type of gauge. It's how you verify accuracy. If you verify accuracy of a type 2 gauge and a type 1 gauge on coded standards, either one, you have to get a magnetic base reading and deduct it. If you verify accuracy with a type 2 gauge on a coded standard and then you adjust the gauge using a measured shim or certified shim over the prepared metal, then you don't need a base metal reading. So it's whether or not you're compensating for the surface roughness. Are you compensating it using a shim over the prepared metal? Don't need a BMR. If you are not compensating for it, then you do need to get a base metal reading. We see people frequently who don't have access on a daily basis to the prepared metal. They only have access to it before it's primed in. They will get a base metal reading that remains their correction value or their base metal effect that they deduct throughout the job because they don't have any place to put a measured shim on the steel is painted. And I know some training courses do teach that you get a base metal with type 1, you don't with type 2, but again, it's not related to the gauge type. It's how you verified accuracy and adjusted that gauge.
Okay. The other question here in regards to BMR and gauges is, do you subtract the BMR on a type 1 gauge from the spot measurement or the area measurement?
You know what, I'd have to actually sit down and look at it mathematically. What I usually get a different question than that, and I want to be careful how I answer it. Usually I get, do I subtract it from my individual gauge readings, or can I wait until I average those three in my spot measurements? And in there, it doesn't make any difference. All right, you can deduct it from the individual gauge readings, or once you average those three readings together to create a spot measurement, then you can deduct it. I wouldn't wait until all at the end, because remember, there is a tolerance on a spot measurement and an area measurement. So you want to have all the corrections done at the spot measurement phase of your data acquisition.
Okay, we have time for I think maybe two more questions, but I encourage everyone to continue to send their questions in. Is it appropriate to use PA2 for thermal spray coating?
That is a great question and something I should have brought up. The 2015 version of PA2, section 1.5 under scope, clearly said that PA2 was not to be used for measurement of thermal spray coatings, that the SSPC CS23 standard had its own procedure in there for measurement of thermal spray coatings. When CS23 was overhauled in 2016, it now references SSPC PA2 restriction level 4, I believe. You'd have to look it up. I believe that's correct. So one of the editorial revisions that was made to PA2 in August of last year was removing that statement from PA2 saying don't use this, because it is very applicable now. In fact, you know, the thermal spray coating standard now references PA2.
All right, great. Well,
Great question.
oh yeah, absolutely. Well, let's see. Actually, I see another question that just popped in here, and I did say we try to do two more, so let's see if this one works here. All right. Yeah, go ahead if you want to answer this one, Bill. This one here says, what are your thoughts on the use of measured shims versus certified shims to verify BMR or gauge accuracy?
Yeah, verifying gauge accuracy needs to be done with a traceable coded standard or a certified shim, because you are now verifying whether that gauge can actually work properly, is actually within its tolerance. So you want to eliminate as much as you can of any outside effects. But when you are actually making adjustments to the gauge to compensate for surface roughness, curvature, metallurgy on the actual structure, measured shims, the ones that come with the gauge, that have the actual value on the shim, those are acceptable to PA2. You can use certified shims as well, obviously, but a lot of people like to keep those, you know, because they're certified in really good condition, and use the measured ones that can be replaced for a few dollars if they get lost or bent for adjustment.
All right, great. Well, with that, we're going to wrap the Q&A, and there are a couple more topics I just want to discuss with everybody before we finish up today's webinar. First thing, I did mention earlier during the webinar, at the beginning rather, there is a test, a quiz through SSPC. Cost is $25. But is free for SSPC members. All you need to do is visit www.sspc.org/market-place. Actually, I believe the website's been updated to www.sspc.org/marketplace. There you can receive, I believe, 1 credit unit from SSPC or the Florida Board of Professional Engineers. Again, sspc.org/marketplace. We are recording today's webinar, and we will make the recording available by the end of the day today. We're looking at around 5 p.m. Eastern Time. So in order to find today's recording, please visit PaintSquare.com/webinars and click on the title of today's webinar, using SSPC PA2 effectively. We are also going to post the slides for today's webinar, and they should be up on the site within the next hour or so. Again, all that information can be found by going to PaintSquare.com/webinars. If you're not already receiving the PaintSquare News Daily e-newsletter, we encourage you to sign up at paintsquare.com/PSN. You can find news, features, quizzes, and coding forums to help you out in the industrial coatings community. Again, paintsquare.com/PSN. And finally, I want to thank Bill Corbett, and I also want to thank today's sponsor, DeFelsco, for today's webinar. We hope to create and present more webinars that are helpful, useful, and informative for your work. This concludes today's webinar. Have a great day, everyone.